Naomi, thanks for the great question. So let's just imagine that you have some, 3 points and two of them are zeros. So I'm gonna show three different examples, and you have to kind of decide which one you're gonna use. So if we have a parabola going through these, what do you know? Well, since we know the zeros, we can write this as y equals some constant times x plus 1, x minus 3. Because if you write it in factored form, this will give you the 0, x equals negative 1, which is right here. This will give you the 0, x equals 3, which is right here. But then the question is, the effect of a is it can stretch and flip our graph. So we know another point here, 0, 1. So if we plug that point in, we know that when x is 0, y is 1. So 1 equals a, 1 times negative 3, because I'm plugging in 0 for x here and here. So that lets us know that a then must be negative 1/3. So our graph is y equals negative 1/3 x plus 1 times x minus 3. Okay, well now let's say here you're given a vertex. So you're given a vertex, at some other point. So if you're given a vertex, well let's use our vertex form. So we know that that's going to be y equals a x minus 2 minus 3 x minus 2 squared. And that's just putting it in vertex form, where we know that our vertex, given the vertex hk, we have a x minus h squared plus k. Okay, so now since we need to figure out what value is a. So let's put in the point that we know, 4, 2. So we're going to put in that point 4, 2 to find out our a value. So if we put in the point 4, 2, we get 2 equals a, 4 minus 2 squared. So we have 4 minus 2 squared minus 3. And then just doing a little rearranging, move the 3 over. We have 5 equals a times, well, this is 2 squared, so that's 4. Therefore, a equals 5/4. And voila, we have figured out what we're looking for, because now we know the a value and we have the vertex form, so we can write our equation as y equals 5/4 x minus 2 squared minus 3. Okay, we're going to do one more example. Okay, sometimes you don't have a lot of really nice points, so we don't have 2 zeros and we don't have the vertex. So if all else fails, you can always create a system of equations where if you write it in standard form, so the three things that we're looking for are a, b, and c. So we have 3 unknowns and we've got 3 points. So if we plug each one of these points are an x, y coordinate. So if you plug each of those points into our standard form, we're going to get a nice system of equations. Now it takes a little bit of work to solve, but okay. So if we plug this point in, we've got my x value is negative 1, my y value is 1, so we have 1 equals a x squared, which is just 1, plus bx, which is b times negative 1, plus c. So rearranging it, we have 1 equals a minus b plus c. And then if we plug this point in, that's when y is 0, x is 2, so you're going to get 0 equals, well, plugging 2 in here, you're going to get 4a plus 2b plus c. Again, we just stuck the 2 into x. So here's equation 1, equation 2, and to get equation 3, we're plugging in the point 3, 1, so you're going to get 1 equals, well, now we're plugging in 3 into x squared, so 9a plus 3b plus c. So this is, I'm not going to go ahead and do this, but you've got 3 variables, 3 equations, and so you could go ahead and either use some sort of software to generate that, or go ahead and solve the system of equations. But typically, we're going to give the problems like the previous ones where you have two zeros or a vertex. So I hope that helps.